During a chemical reaction, the temperature of a mixture dropped by 10.0 degrees Celsius. By how much did the temperature drop in Kelvin? A. 10.0 Kelvin, B. 283.15 Kelvin, or C. 263.15 Kelvin. To convert temperature readings from Celsius to Kelvin, we simply add 273.15 to the Celsius reading. However, this question deals with a temperature change. The question states that the temperature dropped by 10.0 degrees Celsius. The conversion formula is different in this case. Let's see why. Suppose we start with a Celsius reading of C1. The corresponding Kelvin temperature, K1, is C1 plus 273.15. Similarly, the Kelvin temperature corresponding to a Celsius reading of C2 is K2, which is equal to C2 plus 273.15. Now let's take the difference. K2 minus K1 equals C2 minus C1. Note that 273.15 cancels out when you take a difference between two temperature readings. It is customary to represent changes in quantities using the Greek letter delta. So we can say that the change in the Kelvin reading, delta K, is simply equal to the change in the Celsius reading, delta C. In other words, a degree change on the Celsius scale corresponds to a change of 1 Kelvin. Therefore, the correct answer is A. A 10-degree change on the Celsius scale corresponds to a 10.0 Kelvin change. Note that we do not say degrees when expressing temperatures in Kelvin. We don't say 10.0 degrees Kelvin, we just say 10.0 Kelvin. Confused? Consider the figure shown here, which puts the Celsius and Kelvin scales side by side. Note that 0 degrees Celsius corresponds to 273.15 Kelvin, and that 10 degrees Celsius corresponds to 283.15 Kelvin. A change of 10 degrees Celsius corresponds to a change of 10 Kelvin. From 273.15 to 283.15, the change is 10. Let's see what happens when the temperature drops from, say, 40 degrees Celsius to 30 degrees Celsius. In this case, we're looking at a drop of 10 degrees Celsius. 40 minus 30 is 10, and a corresponding drop of 10 Kelvin. 313.15 minus 303.15 equals 10.